Welcome to Special Right Triangles. You know who's special to me? No one. I work alone.
First thing we're going to talk about is the 45-45 90-degree triangle theorem. This says in a 45-45 90-degree triangle, both legs are congruent, and the length of the hypotenuse is the length of a leg times rad 2. So all this is saying is that if you have a right triangle, it's a right triangle because one of the angles is 90 degrees, and the two acute angles are both 45 degrees, then the two legs of your right triangles, the two sides that are adjacent to your 90-degree angle, those are going to be congruent to each other. So in this particular figure, segment XY is congruent to segment ZY. The length of your hypotenuse, the side that is opposite that 90-degree angle, that's just going to equal one of the leg measures times rad 2. So you can pick either leg because they're congruent, multiply it by rad 2, and you'll get the hypotenuse length in a 45-45 90-degree triangle.
This ain't no joke. It's example time.
Now, example 1 says find the missing side lengths. Write your answer in simplest radical form if necessary. So here, we are given a right triangle. We know it's a right triangle because of this little red box here, and we know that one of the acute angles is 45 degrees. So what would the other acute angle measure be? Well, I could take 180, subtract 45, subtract 90, and I'm left with 45 degrees. So this is a 45-45 90-degree triangle, which means we can use the theorem we just talked about, which said that in a 45-45 90-degree triangle, the legs, the sides that are adjacent to this 90-degree angle, those are going to be congruent, which we see they are. And our hypotenuse, the side that is opposite our 90-degree angle, that's going to equal one of the leg measures, doesn't matter which one, times rad 2. So I'm going to take one of our leg measures, 5, multiply it by rad 2, and I get that our hypotenuse length is 5 rad 2 inches. Part B, doing the same thing. We are given a right triangle. We know it's a right triangle because of this little red box here. One of the acute angle measures is 45 degrees, which makes the other acute angle measure, as we just saw, 45 degrees as well, which means we have a 45-45 90-degree triangle, which means we can use the theorem that we just talked about, which said that in a 45-45 90-degree triangle, the legs, the sides that are adjacent to our 90-degree angle, those are congruent to each other, and the hypotenuse, the side that is opposite our 90-degree angle, that's going to equal one of the leg measures times rad 2. Well, in the previous example, we were given the legs and we had to find the hypotenuse, which was pretty easy, right? You just took the leg measure, multiply it by rad 2, and you get the hypotenuse. This time we're given the hypotenuse and we're trying to find the leg. So we're going to still use the same equation. The hypotenuse is equal to one of the leg measures times rad 2. The only difference here is now we're going to plug in a value for our hypotenuse and solve for our leg. So we're going to plug in 4 feet for our hypotenuse and we're going to plug in A for our leg measure. And now we have to solve for A. So how do we solve this for A? Well, we need to get A by itself. So we need to divide both sides by rad 2. And if we divide both sides by rad 2, they cancel out over here. And on this side, we get A is equal to 4 over rad 2. But we can't leave a radical in the denominator. We have to rationalize this fraction. How do we do that? We multiply the numerator and denominator by that radical that is in the denominator. So we're going to multiply the numerator and denominator by rad 2. The reason we do that is because this is a form of 1. Rad 2 over rad 2 is technically 1, which means it doesn't actually change our number, but it will get rid of this radical in our denominator because rad 2 times rad 2 is rad 4, which the square root of 4 is 2. So we get 4 rad 2 over 2, and the 4 and the 2 then simplify to give us 2 rad 2 feet. That's going to be the measure of A, both of our legs.
I founded the Justice League, and I'm basically just a rich guy. You try.
Okay, doing the same thing here. Again, we are given a right triangle here. We know it's a right triangle because of this little red box. And one of our acute angle measures is 45 degrees, meaning that the other acute angle measure, you take 180, subtract 90, subtract 45, you're left with 45. Meaning we have a 45-45 90-degree triangle. So we can use that theorem, which says that in a 45-45 90-degree triangle, the legs are congruent, which we see that they are, and our hypotenuse is going to be equal to one of the leg measures times rad 2. So to get our hypotenuse here, H, I'm going to plug that in here. I'm going to take one of our leg measures, 9 meters, plug that in here, multiply it by rad 2, and I get that our hypotenuse has to equal 9 rad 2 meters. Part B, doing the same thing. We're given a right triangle. We know that because of this little red box here. One of our acute angle measures is 45 degrees, which means, we've seen this already a couple times, that the other acute angle measure has to be 45 degrees. Meaning we have a 45-45 90-degree triangle, which means we can use the 45-45 90-degree triangle theorem, which says that in a 45-45 90-degree triangle, the legs are congruent and the hypotenuse, the side that is opposite the 90-degree angle, is going to equal one of the leg measures times rad 2. Now, in this particular instance, we are again given the hypotenuse measure and we're solving for the leg. We still use the exact same equation. We just plug in what we know. We know that the hypotenuse is equal to rad 2 centimeters. So that's going to go in here. We know that our legs are going to measure x. So we plug that in here. Now all we have to do to solve for our leg measure x is just divide both sides by rad 2. Over here, rad 2 divided by rad 2, those cancel each other out, just turn into 1 times x, which is just x. Over here, rad 2 over rad 2. Those also cancel each other out and just turn into 1. So here we get x is equal to 1 centimeter, and you're done. Now let's talk about the 30, 60, 90 degree triangle theorem. This says in a 30, 60, 90 degree triangle, the length of the hypotenuse is the length of the shorter leg times 2. The length of the longer leg is the length of the shorter leg times rad 3. So there are two types of special right triangles. There's the 45, 45, 90 degree triangle in which the legs are congruent and the hypotenuse is equal to rad 2 times one of the legs. And then there's the 30, 60, 90 degree triangle in which the hypotenuse, the side that is opposite the 90 degree angle, is going to be equal to 2 times the shorter leg, the side that is opposite the 30 degree angle. And the longer leg, the side that is opposite the 60 degree angle, is going to be equal to rad 3 times the shorter leg. So to recap, everything is based on the shorter leg, the side that's opposite the 30 degree angle. If I multiply the shorter leg by 2, I get the length of the hypotenuse, the side that's opposite the 90 degree angle. If I multiply the shorter leg by rad 3, I get the longer leg, the side that's opposite the 60 degree angle. Now, if you ever forget which leg is the shorter leg, which leg is the longer leg, remember, the shorter leg has to be opposite the smaller angle. The longer leg has to be opposite the bigger angle. And the hypotenuse is always opposite the 90 degree angle. Now example 2 says find the missing side lengths. Write your answer in simplest radical form if necessary. So here we have a right triangle. We know it's a right triangle because of this little red box right here. And we know that one of the acute angle measures is 30 degrees. So I take 180 degrees, subtract 90, subtract 30, and I'm left with 60 degrees, meaning I have a 30, 60, 90 degree triangle, which means I can use the 30, 60, 90 degree triangle theorem, which says the length of the hypotenuse, the side that's opposite the 90 degree angle, is equal to 2 times the length of the shorter leg, the side that's opposite the 30 degree angle. And the length of the longer leg, the side that's opposite the 60 degree angle, is equal to rad 3 times the length of the shorter leg, the side that's opposite the 30 degree angle. So the question is, when there's two unknowns like this, which variable do you solve for first? Well, if you recall, everything is based on the shorter leg in a 30, 60, 90 degree triangle. So if you're not given the shorter leg, you need to solve for that first. So we need to find the length of the shorter leg. And the only other length that we're given is the measure of the hypotenuse, the side that's opposite our 90 degree angle. So how are the shorter leg and the hypotenuse related in a 30, 60, 90 degree triangle? Well, the length of the hypotenuse is equal to 2 times the measure of the shorter leg. In this particular instance, our hypotenuse is 8 inches, so we plug that in here. Our shorter leg is y, we plug that in here. And now all we have to do is solve for y. So we divide both sides by 2, and we get y is equal to 4 inches, meaning the measure of our shorter leg, the side that's opposite the 30 degree angle, is going to be equal to 4 inches. Now that I've found my shorter leg, I can easily find the length of my longer leg, the side that's opposite the 60 degree angle, because if you recall, the length of the longer leg is just equal to rad 3 times the length of the shorter leg. So we're going to take the length of our shorter leg, which we found to be 4, we're going to plug that in here. We're going to take the length of our longer leg, which is x, we plug that in here. And all we have to do is solve for x, which is just 4 times rad 3, or 4 rad 3 inches. Part B, we again have a right triangle. We know that because of this little red box right here, where one of the acute angles is 60 degrees. So if we take 180 degrees, subtract 60 degrees, subtract 90 degrees, we're left with the measure of our other angle, which is 30 degrees. Meaning we have a 30, 60, 90 degree triangle, which means I can use the 30, 60, 90 degree triangle theorem, which says that the length of the hypotenuse, the side opposite the 90 degree angle, is equal to 2 times the measure of the shorter leg, the side that's opposite the 30 degree angle. And the length of our longer leg over here, the side that's opposite the 60 degree angle, is equal to rad 3 times the length of our shorter leg over here, the side that's opposite the 30 degree angle. So in this particular example, we have two different variables. Which one do we solve for first? Are we given the shorter leg? Remember, everything is based on the shorter leg. No, it's D. So if you're not given the measure of the shorter leg, you need to solve for the measure of the shorter leg. So we need to find the measure of the shorter leg here. So how do we do that? Well, the only leg measure that we're given is the length of the longer leg, the side that's opposite the 60 degree angle. And we know in a 30, 60, 90 degree triangle that the length of the longer leg is equal to rad 3 times the length of the shorter leg. So we're going to take the length of our shorter leg, d, plug that in here. We're going to take the length of our longer leg, 5, plug that in here. Now all we have to do to find the length of our shorter leg, d, is solve for d. So we divide both sides by rad 3, and we get that d is equal to 5 over rad 3. But again, we have a radical in our denominator. We can't leave it like that. We have to rationalize this fraction. So how do you do that? You multiply the numerator and denominator by the radical that's in the denominator. And that's because this is a form of 1, so it doesn't actually change our fraction. And the reason we do it is because when we multiply these denominators together here, rad 3 times rad 3 is rad 9. And the square root of 9 we know is 3. In our numerator, 5 times rad 3 is just 5 rad 3. So we get that d, our shorter leg in this 30, 60, 90 degree triangle, is equal to 5 rad 3 over 3 feet. Done. Next, we need to figure out what is the length of our hypotenuse. Well, if you remember, the length of the hypotenuse in a 30, 60, 90 degree triangle is just going to be equal to 2 times the length of the shorter leg, the side that's opposite the 30 degree angle. So we're going to take the length of the hypotenuse, f, plug that in here, and we're going to take the length of our shorter leg, 5 rad 3 over 3, and plug that in here. Now all we have to do is simplify. What is 2 times 5 rad 3 over 3? Well, this looks complicated, but 2 is the same as 2 over 1. So I just multiply the numerators together, denominators together, and I get 2 times 5 rad 3. You just multiply the 2 and the 5, you get 10 rad 3. 1 times 3 in our denominator is just 3. So f, our hypotenuse, has to be 10 rad 3 over 3 feet.
I know Robin's trying. Are you trying? You try.
Okay, doing the same thing here. We are again given a right triangle. We know that because of this little red box right here. We are given one of our acute angles is 60 degrees. So what's the measure of our other acute angle? Well, we take 180, subtract 60, subtract 90. We're left with 30 degrees. So we again have a 30, 60, 90 degree right triangle, meaning we can use the 30, 60, 90 degree triangle theorem, which says that the length of the hypotenuse, the side opposite the 90 degree angle, f in this case, is equal to 2 times the length of the shorter leg, the side opposite the 30 degree angle. The length of the longer leg, the side opposite the 60 degree angle, is going to be equal to rad 3 times the length of our shorter leg, g in this case. So we have two variables here, g and f. Which one do we solve for first? Well, remember, in a 30, 60, 90 degree triangle, everything is based on the short leg, the side opposite the 30 degree angle. So if we don't have that, we need to find the shorter leg first. Now, in this particular example, the only side length that we are given is the length of the longest leg. So we're going to have to use that in order to figure out what the length of the shorter leg is. So how are the longer leg and the shorter leg related? Well, we know that the length of the longer leg is equal to rad 3 times the length of the shorter leg. So in this case, we're going to plug in 3 rad 3 for the length of our longer leg. We're going to plug in g for our shorter leg. Now we need to solve for g. So how do we solve this for g? We have to get rid of this rad 3. So we divide both sides by rad 3. When we do that, these rad 3s cancel each other out. On this side, these rad 3s cancel each other out, and we're left with g is equal to 3 yards. So we can replace that over here in our figure, and now we can solve for our hypotenuse, f. So how do we solve for our hypotenuse? Well, again, everything in a 30, 60, 90 degree triangle is based on the shorter leg, the side opposite the 30 degree angle. Our hypotenuse in this case, f, is going to be equal to 2 times the length of the shorter leg. So what we're going to do is we're going to take this formula over here that we have, we're going to plug in f for our hypotenuse, we're going to plug in 3 for the length of the shorter leg, and we get that f, or our hypotenuse in this 30, 60, 90 degree triangle, is equal to 6 yards, and you're done. Now, example 3 says find the measure of each variable, write your answer in simplest radical form if necessary. So this is pretty crazy. We have one really big triangle with 4 different variables that we need to find. So what I'm going to do is, because we're only given this one side length right here, this 7 rad 2 meters in our big triangle, I'm going to break this big triangle down into 2 smaller triangles and see if I can use some of the theorems that we were talking about earlier today. So let's first look at this small triangle over here, because we're only given this one side length. We know that this little angle right here is 45 degrees. We know that this right here is an altitude of this big triangle, meaning it's perpendicular to this side, meaning that if this right here is a right angle, then this over here should also be a right angle. Meaning, if this is 90 degrees and this is 45 degrees, you subtract those from 180 and you get whatever the measure of this angle is, which is 45 degrees. Meaning, in green right here, we have a 45, 45, 90 degree triangle. And we can use our 45, 45, 90 degree triangle theorem in order order to solve for our missing side lengths over here. So what do we know about a 45-45 90-degree triangle? We know that the legs of a 45-45 90-degree triangle, the sides adjacent to our right angle, they must be congruent to each other. And we know that the length of the hypotenuse, the side that is opposite our 90-degree angle, that's going to be equal to rad 2 times the length of a leg. Well, we don't know the length of either of the legs, but we do have the length of our hypotenuse. So we're going to set up that equation where we have the length of the hypotenuse of a 45-45 90-degree triangle is going to be equal to rad 2 times one of the legs. So what we're going to do is we're going to plug in 7 rad 2 for the length of our hypotenuse, and for our leg, we can either plug in A or C. It doesn't matter. I'm going to plug in A. So now I have to solve for A. To solve for A, I'm going to divide both sides by rad 2. Over here, the rad 2's cancel out. Over here, the rad 2's cancel out, and I get A is equal to 7 meters. Now, because the lengths of the legs of a 45-45 90-degree triangle are congruent, I know that their measures must be equal. So if this leg right here is 7 meters, then this leg right here must also be 7 meters, meaning C also has to be 7 meters. Now that I've finished with this green triangle over here, I can move on to this medium-sized triangle over here. Now, what do I know about this? Well, I know that it has a 90-degree angle right here. It has a 30-degree angle over here. And if we take 180 degrees, subtract 30 degrees, and subtract 90 degrees, we are left with the measure of this angle right here, which is 60 degrees, meaning we have created a 30, 60, 90-degree triangle. Now, remember, in a 30, 60, 90-degree triangle, everything is based on the length of your shorter leg, the side that is opposite your 30-degree angle. The length of your hypotenuse, the side that's opposite your 90-degree angle, is going to be equal to 2 times the length of your shorter leg, the side opposite your 30-degree angle. The length of your longer leg, the side that's opposite your 60-degree angle, is going to be equal to rad 3 times the length of your shorter leg. So we obviously have to find our shorter leg first. Oh, we already have it. It's 7 meters, meaning we can either find our hypotenuse or the length of our longer leg first. It doesn't matter. So I'm going to find our hypotenuse first because it's a little easier. We don't have to deal with radicals. So we said that in a 30, 60, 90-degree triangle, the length of the hypotenuse is going to be equal to 2 times the length of our shorter leg. In this case, our hypotenuse, the side opposite our 90-degree angle, is B, so we're going to plug that in here. The length of our shorter leg, the side that's opposite our 30-degree angle, is going to be this 7 meters. We're going to plug that in here. We then multiply 2 times 7, we get that B has to be equal to 14 meters. So we're going to plug that in our triangle up here. Next, we have to find our last variable, which is D. And remember, D is the side that's opposite the 60-degree angle in our 30, 60, 90, making it the longer leg. And the longer leg in a 30, 60, 90 is equal to rad 3 times the length of the shorter leg. So in this case, the length of our longer leg we said was D, so we're going to plug that in here. The length of our shorter leg we already said was the side opposite our 30-degree angle. That's 7, so we plug that in here. And 7 times rad 3 is just 7 rad 3. Because our units are meters, we write 7 rad 3 meters, and we have found all 4 variables. We're done.
I'm busy fighting. You try.
Okay, doing the same thing. We again have this big triangle and we have 1, 2, 3, 4 different variables that we need to solve for. This time we're given a different side length as our given. We're given this 6 centimeters as this measure right here. So we again want to break this down into 2 separate triangles so that we can use some of the theorems that we talked about earlier today. Since we are given this 6 centimeters right here, we're going to look at this triangle up here first. Now, what do we know about this triangle? Well, we know that one of the angles is 60 degrees and one of them is right, meaning it's 90 degrees. So if we take 180 degrees, subtract 60 degrees, subtract 90 degrees, we're left with 30 degrees over here, meaning we have created a 30, 60, 90 degree triangle. What do we know about a 30, 60, 90 degree triangle? Well, everything is based on the short leg. The short leg, the side that's opposite the 30 degree angle, if you multiply that by 2, you get the length of the hypotenuse, the side that's opposite our 90 degree angle. If you take the short leg, the side that's opposite the 30 degree angle, and multiply it by rad 3, you get the length of the longer leg, the side that's opposite the 60 degree angle. So in this 30, 60, 90 degree triangle, we have 2 variables that we need to solve for, A and B. And the question is, which one do you solve for first? Well, since everything is based on the length of the shorter leg, the side opposite the 30 degree angle, we should solve for A first because we can use that to then find B. So because in this particular example, we are given the length of the longer leg, the side that's opposite the 60 degree angle, we need to set up an equation that involves the longer leg and the shorter leg. Well, what's the relationship between those 2 legs? Well, we know that the length of the longer leg, the side that's opposite the 60 degree angle, is going to be equal to rad 3 times the length of the shorter leg, the side that's opposite the 30 degree angle. So I'm going to take the length of the longer leg, which is 6 centimeters, plug that in here. I'm going to take the length of the shorter leg, which is A, and plug that in here. Now all I have to do is solve for A. So how do I solve for a? I divide both sides by rad 3, and over here the rad 3's cancel out. I get a is equal to 6 over rad 3. But I can't leave this with a radical in the denominator. I need to rationalize it. So I'm going to multiply the numerator and denominator by the radical that is in the denominator. I do that because this is a form of 1, so we're not really changing our fraction here, and it's going to get rid of this radical in the denominator because rad 3 times rad 3 gives you rad 9, and the square root of 9 is 3. In our numerator, 6 times rad 3 is just going to be 6 rad 3. Now we can simplify this 6 with this 3. 6 divided by 3 gives you 2, so we know that a has to equal 2 rad 3 centimeters. So we're going to plug that in our figure over here for a. Next, we need to figure out what is our hypotenuse. Well, remember, in a 30, 60, 90 degree triangle, the length of the hypotenuse, the side that's opposite our 90 degree angle, is going to be equal to 2 times the length of our shorter leg, the side that's opposite our 30 degree angle. So we're going to take our hypotenuse in this case, which is b, plug it in here. We're going to take the length of our shorter leg, which is 2 rad 3, plug it in here. Now all we have to do is solve for b by multiplying the 2 times this 2 out front, and we get b, the length of our hypotenuse, is going to be equal to 4 rad 3 centimeters. So we can plug that in our figure over here. Now because we have found each side length in our 30, 60, 90 degree triangle, we can move on to our other triangle down here. What do we know about this triangle? Well, we know that the acute angle right here is 45 degrees. We know that this angle right here, because this segment is perpendicular to this angle must also be 90 degrees. So if we take 180 degrees, subtract 45, subtract 90, we're left with 45 degrees for this angle right here, making this triangle a 45, 45, 90 degree triangle. So what do we know about a 45, 45, 90 degree triangle? Well, we know that the legs, the sides that are adjacent to our 90 degree angle, are going to be congruent, and the hypotenuse, the side that's opposite our 90 degree angle, is going to be equal to rad 2 times the length of one of the legs. So are we going to find C or D first? It doesn't matter because we already have the length of one of our legs. So let's just find the length of our other leg. Since we know that the legs have to be congruent, we know that their measures must be equal. Therefore, if we know that one of the legs is 2 rad 3 centimeters, we know that the other leg, C in this case, also has to be 2 rad 3 centimeters. So we can plug that in there. Next, we said that the hypotenuse was equal to rad 2 times the length of one of the legs. So we take the length of one of the legs, we plug that in over here, and we take D, which is our hypotenuse, plug it in here. And we get that D is equal to 2 rad 3 times rad 2. Now, how do you multiply these together? Well, you just multiply whatever's under the radical together. So it's going to be rad 3 times rad 2, which gives you rad 6. Then we multiply that to the 2 out front, and we get D has to be equal to 2 rad 6 centimeters. And you're done. Now, word problem says Toblerone sells their chocolate with packaging in the shape of a triangular prism. Given that the ends of the package form equilateral triangles with lengths of 2.4 inches, what is the maximum height the triangular chocolate could be and still fit in the packaging? Round your answer to the nearest 100. So step 1 in a word problem, we're not scared, we can do this. Step 2, we need to define our variables. So what is this question asking us to find? It says, what is the maximum height the triangular chocolate could be and still fit in the packaging? So we're going to say H is going to be the maximum height for our triangular chocolate. Next, we need to write our equation. So the equation that we're going to solve for H, we need to figure out what that is. Well, what else does it give us in the problem? It says that the ends of our packaging are equilateral triangles with side lengths of 2.4 inches. So let's make a quick sketch of what this looks like. We know that the ends of our packaging are equilateral triangles with side lengths of 2.4 inches. We also know that an equilateral triangle is both equilateral and equiangular, meaning each of these angle measures in here must be 60 degrees. And we are trying to find the height of this packaging, because if we determine the height of this packaging, we know the maximum height the triangular chocolate could be. So how do we figure out what H is here? Well, if you see, when we drop this altitude down here, this height, we have actually cut this angle up here perfectly in half because it's an equilateral triangle. We know that this angle up here must be bisected. So instead of being one big 60-degree angle, it's going to be two small 30-degree angles. So what we've done is actually create two separate 30, 60, 90-degree triangles. And we can use the theorem we talked about earlier today in order to help us find the height here. Since we know that this height right here is going to be the longer leg of our 30, 60, 90-degree triangle, we just have to figure out what is the shorter leg. What's the side opposite our 30-degree angle? If we know that, we can just multiply that by rad 3, and that'll give us the length of our longer leg, our height. Well, this whole side length is 2.4 inches. Again, since this is an equilateral triangle, the height, the altitude right here, not only bisected this angle up here, but it also bisects this side, meaning each of these little side lengths must be 1.4 1.2 inches each. Now we know what the length of the shorter leg of our 30, 69 degree triangle is, so all we have to do is take the length of that shorter leg, multiply it by rad 3, and it'll give us the length of our longer leg. So we can plug these values into our equation over here. H is going to be the length of our longer leg. 1.2 inches is going to be the length of our shorter leg. So we take 1.2 multiplied by rad 3, and since it wants us to round to the nearest hundredth, we could just plug this in our calculator. And when we do and round to the nearest hundredth, we get H is approximately equal to 2.08 inches, meaning that the height of the chocolate must be less than or equal to 2.08 inches because that's the height of the packaging. And if the height of the chocolate is any taller, it won't fit into the packaging.